So your lesson for 6.1 is, it's a good one. You are going to be solving systems using matrix operations. Now, technically, I'm supposed to show you what is referred to as the Gaussian method of elimination. So what I should be doing first is showing you how to solve this system through good old-fashioned algebra, which we could, and maybe if we have time today, I'll show you at the end. We'll see. But then we're going to show you about an alternative technique for solving this system. That's writing an augmented matrix. So let's start there with some vocab. This is what an augmented matrix looks like. You take your system and you align all the variable terms in the exact same order all the way down to the solutions. So like X, Y, Z solution is the order they went with for this matrix. So notice what they have here for the augmented matrix is they have all the coefficients listed in that exact same order, signs included. And then this line right here is not actually there. They just help you separate the body of the system from the solutions of the system. So think about your knowledge from yesterday, guys. What are the dimensions of this matrix? 3 by 4. 3 by 4 technically, because this last one is part of the matrix as well. So what we're going to be doing in a minute is we're just going to jump straight to the calculator. But this is, I'll just give you a little preview of what we skipped. So we took this out of the curriculum. It's called row operations. Your calculator does them for you, which is kind of nice, but you have to command it to do every operation. So like, for instance, you know what? They don't have a good slide here. Skip that for a second. I'm not even going to talk to you about row operations, guys. Here's what's happening. Your job is to get the matrix to look like this, where the identity matrix is on the left side and you have solutions on the right side. So it's a series of things like add row 1 plus row 2 together and then see what happens. And then you place it back in row 1. It's very complicated and very irritating. And I feel like a good majority of my high school life was robbed from me because I had to spend hours upon hours doing row operations. And then at the end of learning all of that, my teacher said, oh, by the way, there's this other way to do it, and it takes you like 30 seconds, and you're like, great. So row operations aren't really used. It's kind of cool. I'm sure something like them is valuable somewhere in the world, but not in a high school classroom. So we're going to skip the row operation section. Here's the idea. If your calculator can get you down to an identity matrix, look what's happening here, guys. It has a 1, 0, 0, a 1 in the Y position, and then a 1 in the Z position. This guy right here is telling you the solution. It says 1x equals -2. 1y equals 1. And 1z equals 3. So the whole point of a system is to find the solution. And if you think back to our question, the very beginning of our question here, you were supposed to find all the variables, x, y, and z. That's all our goal is today, guys. So all I need to show you is how do you do this on the calculator. So do me a favor and flip to, you know what, all the way to the back. Look at 8b. Where does 8b start? I don't even know where it starts. Is this it? Yeah, all right. So, the command on your calculator that we're going to be using today is RREF. And that is an acronym for row reduced echelon form. Yeah, look up at the spelling. It's on your paper too. Echelon. So your calculator is going to take a very much not reduced matrix. It's going to very quickly perform a bunch of row operations, and it's going to create a row reduced echelon form matrix that's going to look like this. Where for us it's going to be 3 by 3 bodies, so it's going to look 1 0 0 0 1 0 0 0 1. That's going to be the beginning of your matrix, and then over here you're going to have 3 solutions. You're going to have a solution for x, you're going to have a solution for y, and you're going to have a solution for z. Your only job is to interpret the solution. So enter the matrix, command it, interpret the solution. You guys don't actually have to do much work today at all. So that's good. We're going to come back to the idea of infinitely many solutions and no solutions in a second. Let's just get the regular ones out of the way, and then we'll come back and look at the weird ones. So on your paper, can you find, apparently we're not doing 1, can you find, you know what, I like number 1. Let's uncross that out. Number 1. What we need to do is we need to enter this system as a matrix. And we're going to enter it as an augmented matrix. Now on your test, I'm going to ask you, how are you entering this in your calculator? So you're going to write your augmented matrix with just the coefficients. Make sure you're staying in order, x, y, z solution. So your augmented matrix would be -2, -1, 1, 0. 1, 2, -1, -3. Try again. And then 3, 1, -2, -1. This is literally how you're going to type in this matrix. However, on your paper, it might benefit you if you kind of separate the body from the solution just so your eyes can see it. That's when they say write the augmented matrix on your paper, this is what I'm looking for. So now on your calculator, you're going to go to Matrix, and you're going to go over to Edit, and choose whatever matrix you want. I'm going to go with matrix A. I'm going to pause the video. My viewers are going to pause the video as well and enter their matrix in this dimension. Remember, you guys told me this was a 3x4. All right, so we have our matrix A entered. I'm going to go back to the home screen. Whoops, or not. So you just make sure nothing's going on your home screen right now. I do this a lot where like I partially commanded something because I typed bad. But go back to the matrix menu, and this time you're going to calculate something. So you're going to go to its math menu. And we said at the top of our notes, what we're going to command it to do is find RREF, row reduced echelon form. Now be careful. There's REF and then there's RREF. So make sure you're choosing choice B, row reduced echelon form. And then you have to tell it who to row reduce echelon form to, so which is matrix A. So inside that command, pull up the name for matrix A, if that's where you put your matrix, and then hit enter. Solution. So this is the solution matrix. The body is what we call the identity matrix. So it says 1x equals 2, and 1y equals -1, and 1z equals 3. So the way we're going to write that answer, guys, we're not going to write x equals y equals z equals. We're just going to write an ordered triple like we always would. X, y, z. Beautiful. Okay. So let's take a, oh, I didn't write that down here. Was it 2, -1, 3? Thank you. So that's the solution. So on your test, I'm going to ask you to do 2 things for me. I'm going to say, write it as an augmented matrix, which is this, and then figure out the solution. Now, if you want, when we have time later, guys, I can show you how to solve this by hand, but I can't think of a soul in here who would be like, yes, let me solve that by hand, because it's a waste of your time, frankly. But I'll show you later if you're interested. All right, guys, let's look at number 2. Let's talk about the augmented matrix for number 2. So remember, it has to go in the exact same order for every single part of your system. So we have coefficients of -4, -1, -1, and then -11 on the solution part. And again, for the augmented matrix, it's smart if you separate your body from the solution. Now, talk to me about the second line. Where is the 0? For the y, good. So it's 1x, no y's, -1 z's, and 2 is your solution. That was really nasty of them to write it that way. I think on your test, Mrs. Hoffbauer was super nice to you, and she lined everything up like right underneath the other variables, which is very kind. What are the coefficients for this last equation? 0 x's, 2's, 4 z's, yep, and 0 for a solution. All right, so you're going to have to pause the video so you can get this matrix entered. You can just overtype on matrix A because you don't need that old one anymore. And then you're going to go on your calc again and you're going to command it to RREF, matrix A. Or wherever you put it, I guess. So according to my last year's key, I got the solution x equals 3, y equals -2, and z equals 1. Which I'm getting some confirmation on that. Cool. All right, so we need to go back and investigate what happens when we don't have a normal solution like this. So back in our notes at the beginning of this page, it started to talk to you about cases where your system had no solution and cases where your system had infinitely many solutions. So ignore all this row operation business and let's talk about what happens right here. There is a question on your test that looks almost identical to this. Okay, so it gives you 3 scenarios of matrices that you've performed RREF on somehow, and this is what your calculator would spit out to you. So interpret this first one for me. It says x equals 19. Got it. And then this line says y equals 4. Got it. And then this line says z equals -20. So that is a unique solution where you would write it as an ordered triple, 19, 4, -20. That's what we just saw a couple examples of. Now let's interpret this one. This top row, I need you to translate that for me. It says 1x minus z equals 0. That's weird. It almost looks like it's not done, right? All right, let's look at this middle row. Translate that for me. It says 1y plus 2z equals 0. And then look at this mess. What does that line say? 0 equals 1. What now? Sounds about right to you? 0. Okay, 0 does not equal 1. So that's the issue here. Since 0 does not equal 1 and cannot equal 1, this is a case where you have no solution. So you don't actually have to do any work in this case. You just say there's no solution. But let's look at this third example. This is the fun one. All right, translate this first row for me. Ugh. It says 1x, yep, minus 6z equals 4. And then this middle line, 1y plus 2z equals -3. And this is interesting. Okay, so, whoops, that's a 0. 0 does equal 0. And we get this in algebra quite a bit, where like you get a true statement, but like not a helpful statement. Like 0 equals 0, but that doesn't tell you anything. It doesn't tell me anything about a variable that usually shows up in my third row, which is z. So what we're going to do, we're going to have many solutions in this case. But I'm going to ask you to go one step further. I know there's many solutions. I need you to give me a formula that will provide all those many solutions. So what you're going to do is, because the z variable is not really defined for you anywhere, we're going to let z just be z. How very clever. And then what I'm going to have you do is go back to these other 2 lines and solve for x and solve for y. So rewrite these 2 formulas so that it says x equals some mess and y equals some mess. So that green one becomes x equals, you can say 4 plus 6z, or you can say 6z plus 4, it doesn't matter. And then that red one becomes y equals -2z minus 3, or you could say -3 minus 2z, yes. So how does that help you? Well, because now you can technically write an ordered triple. This is weird, guys. It's pretty big. Watch out. Instead of x, you're going to write that. Instead of y, you're going to write that. And then, what is z? Z. Clever, Abruzzo. That is what an ordered triple would look like in the case of many solutions. So the reason it's many solutions is because you can type anything you want in place of z, and you'd get an ordered triple. And then you could type something else in place of z, and you'd get a different ordered triple. And then you could type something else. So you can see how this would provide many, many, many solutions. I think there's some homework problems, unless we crossed them off, where it says, come up with this generic formula, and then it says, give me 2 examples of solutions that work. So in that case, what you do is you pick your favorite 2 numbers, So like 7, you'd plug in 7, get an ordered triple, and then your next favorite number, which clearly is 10, and you plug in a 10 and you get another ordered triple, and those are two cases of solutions that would work for this system. The problem is you're not going to get what's called a unique solution. So on your test and on your post-test coming up shortly, you're going to have a question that looks just like this. 3 weird-looking augmented matrices where one of them has a unique solution, that you give an ordered triple, one of them has no solution, so that's easy, and then the one that has many solutions, you got to do a little work too. So, sorry. All right, questions so far? Let's see this in action. Can you look at number 3 on your notes? And I'm going to need you to first write down what your augmented matrix is. A little practice with that. So -3, 4, -1, -10. 6, -1, -5, -29. Why can I never space this out right? And then 4, -5, 1, and 11. So pause the video, get your matrix entered, and then perform RREF on this matrix. So after performing RREF on that matrix, we get this type of a solution. So think about the 3 examples we just saw. This is not a case where you get a unique ordered triple. So is this many solutions or no solution? And the key is, look at this line. Does 0 equal 0? Yeah. So this is a case where we're just going to say z is z, and we're going to have many solutions. But you guys have to do a little better than that and actually give me an ordered triple that would find any of those many solutions. So, just like we did in that first example, you take your first line and you set it up. You translate it. You say x minus z equals -6. And then you solve it for x. So x is z minus 6. And then you do that same thing for your middle line. You translate it, and then you solve it for y. I need room. All right, y minus z equals -7. So when you solve for y, you get z minus 7. And here we go. Ordered triple. Well, z is z. That's boring. Y we just found to be z minus 7. And then x is z minus 6. And that is the solution recipe that'll find any of those many solutions that you're looking for. Okay? So, one more, and then I'll leave you alone. No, I lied. Spoiler alert, number 4 comes out to no solution. And here's why. When you get to the bottom row, it says 0 plus 0 plus 0 equals 1. So, in your RREF matrix, guys, 0 does not equal 1, so that means that this is no solution. I want to talk about number 5 because that's a good application of how this matrix could be used. So we have a company that manufactures tables, chairs, and stools. Last week it built a total of 275 items. The number of chairs was built 4 times. Oh boy, it was 4. Oh gosh, this is a lot harder than it looks. Here we go. All right, so first of all, let's come up with some variables. This time, I don't want you to get very creative, guys. I want you to go old school and just call them x and y and z. So what do you want x to represent? Number of tables? Okay. So y must represent number of chairs. And z will represent the number of stools. So that first clue where it says the total number of items is 275, that's a pretty boring equation where it just says x plus y plus z equals 275. Now this sentence, the number of chairs that was built was 4 times the number of tables and stools built. So let's translate that. The number of chairs, which is y, is, which means equals, was, is equals, 4 times the number of tables and stools built together. So 4 times tables and stools. That's a little hard to translate. We have a question coming up in the future that's about like cupcakes and cookies for a fundraiser, and we got to really think about those equations. The total value of these items is 42,125, and a chair is 150, a table is 200, and a stool is 75. Now be careful because of the way we define these. All this money stuff goes together in one equation, but a table is 200, so it's like 200x, and then where's chairs? 150, so 150y, and then a stool is 75z, and it totals 42125. So I think we can all agree using the matrix RREF command is awesome. Unfortunately, it only accepts the command if you write an augmented matrix in the correct form. This is not even close to the right, well, it's close. The problem is that green equation. I'm going to need you guys to modify this green equation so it's in our x plus y plus z equals number form. So first thing you're going to need to do is distribute the 4. And then I would just subtract the y over and say 0 equals 4x plus 4z minus y. But then you're going to have to remember that that's backwards. Not that that's a huge deal, but flip it around. So when you go to enter your matrix, your augmented matrix, oh boy, your coefficients are, for this top one, that's easy, 1, 1, 1, 275. For this green one, it's 4, 4, negative 1, 0. And then for this blue one, it's 200, 150, yuck, 75, and 42, 125. What did I screw up? Say again, I'm sorry. Oh, thank you. That's bad. This is not at all in the right order. Reverse these. Good call. So, a little bit of a drawback. When you have a real-life question, generally things are not in the form you want them in, so you got to do a little manipulation, and double drawback if you don't pay attention like your teacher, you're going to get it wrong. So get that entered into your matrix, perform RREF, and I'm hoping we get a unique solution because we're supposed to. So after performing RREF, you get the ordered triple, and then you have to go back to your x, y, and z variable definitions at the beginning. And hopefully you didn't make any mistakes like I did. But that's your solution. Alright, so you guys do have a bookwork assignment. It's really, really important that you practice these because I know you feel like they're really easy, but this is all about muscle memory. And now I want you to find worksheet 9. Let's have a lot of fun on worksheet 9. I'm going to show you a really cool application of how you could use a matrix to solve a really complicated question. And by the way, worksheet 9 is part of your homework check. They're going to ask me which part, and I'm not going to know. Anyone have their homework list out? What did I assign on worksheet 9? Okay. So I'm going to make sure I don't do 2 or 6, so you can do them. Right? Let's do number 1. Now, there's an awful lot of space there for a question that doesn't look like it needs it. Turns out this question does need a lot of space because we're going to use an augmented matrix, a system of equations, in order to calculate this. So this is another way for us to calculate a regression equation when given ordered pairs. So this is a cubic function. We know, like technically on our calculator, we could just type them into list 1 and list 2 and do cubic regression and we'd be in good shape. But maybe you're curious like how cubic regression is calculated. Let me show you. So these are all XY ordered pairs. And then we have a skeletal function of a cubic equation with mystery coefficients, A, B, C, and D. So how do we find A, B, C, and D? So the rule of systems is for every unknown thing, you need that many equations. So if you have 4 unknown quantities, you're going to have to set up 4 equations for me. Well, looky here, guys. You've got 1, 2, 3, 4 ordered pairs. Let's see what happens. All right, what we're going to do is we're going to set up an equation based off of each of the ordered pairs. So let's start with this ordered pair. If x equals 1 when y equals 4, I'm going to plug that into this function, and I'm not going to do any work. I'm just going to set it up. So I have y, so 4 equals a times x to the third, so 1 to the third, plus b times 1 to the second, plus c times 1, and then plus d. And now we got to do that for all the other ordered pairs. So this next ordered pair would be 14 equals a times, this time it's negative 1 to the third. Oops, not that. So plugging in negative 1 for all these x's this time. And then our third ordered pair says negative 19 equals all that. But this time you're plugging in 2 for all your x's. And then there's that final ordered pair. Whew. You guys are going to be mad at me when I tell you we're not ready for the matrix yet. So remember, if you're trying to use an augmented matrix, you have to have an augmented matrix which steals all the coefficients in x, y, and z order, or in this case, A, B, C, D order. So what we're going to need to do is write this as an augmented matrix, which first of all you need to flip it around. And then the second thing you're going to have to recognize is that all your coefficients need to be simplified. So like for instance, well that one's not too hard, but 1 to the third is 1, 1 to the second is 1, 1 is 1. And what's the coefficient on all of these z's? They're all 1s, so that's boring. But then, remember it's augmented, so the solution goes next. So on that first one, I should have done these in blue, my bad. That first one has a solution at 4. So for this red line, your first coefficient is negative 1 to the third power, which is really negative 1. And then negative 1 squared is positive 1. And then a negative 1. And then a positive 1. And the solution part of that red line is 14. All right, for the green line, 2 to the third is really an 8. 2 squared is 4. And then we got a 2. And we got a 1. And the solution part of that is negative 19. And then that last one, negative 2 to the third power is negative, oh, wrong color, negative 8. And then positive 4, negative 2, positive 1, solution at 49. All right, thank goodness. There's going to be no more thinking on your part. Here you go. Get this calculated into your calculator, command it to find the row reduced echelon form of this matrix, wherever you're entering it. And then you're going to get, I guess you called it an ordered quadruple. So through your augmented matrix, commanding it for RREF, you get the ordered quadruple, negative 4, 2, negative 1, and 7. So you got to think back, okay, what did all these coefficients represent? So this first one, this is your A coefficient. And then this next one is your B coefficient. And then this is C. And then this last one is D. So we're not done. We're kind of done. You just got to put them in the right spot. So remember, way at the beginning of the question, it said write the equation. So you just need to put A, B, C, and D in the right spot for that skeletal equation. So y equals, A was what? Was it negative 4? So negative 4 x to the third, yeah, okay, plus 2x squared. You can say minus 1x, or you can just say minus x, plus 7. Ta-da! That's how you can do regression. And I'm going to say by hand, but not really, because we still cheated and used our calculator. Can you imagine doing that by hand? No, because I haven't shown you how yet, but it's terrible. You trust me when I tell you it's awful. All right. Let's get, you know what? It's almost the holidays. I'll do number 2 with you. Is that one of your assigned problems? That sounds like a fair deal. Isn't that nice? All right. So, guess what, guys? It's very similar. First ordered pair. So its formula starts off with, you know what? I'm going to be smart. Let's flip this equation around. Let's put the solution on the other side for once. All right. So I'm going to write the y equals part over here. So basically, I'm doing this. So ax squared. So we got, or ax to the third. So a times x to the third So I know that first equation is kind of boring, but you still need to write it down. All right, next equation. This time you're using 2 for x and 1 for y. So a times 2 to the third plus b times 2 squared plus c times 2 plus d, and it equals 1. Okay, we have a third equation now. Alrighty, equals 55. And then final equation is going to use this 8, 7, 15. Okay. Whew, good times. All right, so that's not what you're entering in your calculator. In your calculator, oh boy, I should have wrote that smaller. You are entering, let's see, for the blue line, we got, oh, my pen's not working. Come on, pen. Okay, for the blue line, you have, oh, that's not blue. 1, 1, 1, 1, and 1. For the red line, you've got 8, 4, 2, 1, and 1. For the green one, you have, is that 64? Okay, so 64, 16, 4, 1, and 55. And then for the black line, you, oh, I don't know. What's that? 512, okay. 512, 64, 8, 1, and 715. And that is all the math we're going to do on that question. The rest of it's going to be on the calculator. So, getting your ordered quadruple, enter, enter. Right, so, those are the coefficients for a, b, c, and d. So when I go to write the equation, I'm going to write down 2x to the third minus 5x squared plus 1x plus 3. That's nice. I did one of your homework questions there. So you guys have to do number 6 is the next one on that side. And then on the back of worksheet 9, can you tell me what you're assigned? 2 and 4, all fantastic questions. Those go back to regular 2-variable systems, but here's the good news, guys. You can technically use your matrices, RREF, to solve any systems as long as it doesn't indicate otherwise. So if you want to use matrices to solve 2 and 5 on the back, you go right ahead. So you can set it up and do RREF if you like. I'll be honest, I hate typing matrices, so you won't really find me electing to do a matrix unless it's at least a 3x3 or 3x4, because I don't really like typing them. All right, you have bookwork assigned to you, and then you have worksheet 9 also now assigned to you. Tomorrow and Friday, we have to we got to finish this up. I know it feels like we just started this chapter, because we did. We're actually about to finish it. So get caught up on your homework, guys. Otherwise, you're going to have a very arduous weekend ahead of you. And remember, our final summative 12, is on Tuesday. I'm going to put a calendar up on the board, and then I will post it on Google Classroom as well in case you're curious what the hey is going on.